Hello, in this video we're going to look at the graph of sine of x, the basic sine wave, and we're also going to look at some transformations on that sine wave. Now, the way I set these up is we're looking at y equals sine x. I set up a table like this. The top line is going to be x. Below that, because it's just sine x, we're going to just put sine x. If this is a sine of 4x or something like that, what we're going to do next, then I would put another line in my table. I'll show you all that when we get there. Now, we're going to let x take on certain values. These are the values that I plot. I want the period of sine is 2 pi. So I want to make sure I get to 2 pi. This gives me some of the special values of sine from 0 to 2 pi. The numbers that I use are 0, power 2, pi, 3 power 2, and 2 pi. I use those same numbers for sine, cosine. Actually, I use them for all of them. Tangent, cotangent, everything. Everything comes out of sine, cosine. Now, let's sketch the graph. You want to do this on graph paper. You want your graph to be fairly accurate and pretty. When you do a graph on graph paper, you need to show an x-axis labeled, a y-axis labeled, and show what the scale is. A pretty good rule of thumb is, if you look at the distance between here and here, from 0 to power 2, is power 2 units. So, a pretty good rule of thumb is to let your scale on the x-axis be half of that distance. I'm not going to do that on this example. In this example, because of the one I'm going to do after this, I'm setting it up on a different scale. So normally I would let one tick mark on the x-axis for just the sine wave be pi over 4 units. This time I'm going to make it pi over 8 units. So one tick mark on the x-axis is pi over 8. So pi over 8, pi over 2 is the same as 4 pi over 8. So here is 1, 2, 3, 4 pi over 8. 5, 6, 7, 8 pi over 8. Or pi. This is pi over 2. Alright, this is 8, 9, 10, 11, 12. That'll be 3 pi over 2. And I ran myself out of graph paper. But if I go the other way, we'll get there. Alright, plot these points. The point 0, 0, and I use these points because the sign is going to be either 0 or 1 or negative 1 at these points. Now, at pi over 2, or 0, the sign is 0. At pi over 2, the sign is up to 1. At pi over 2, I'm up to 1. At pi, I'm back to 0. At 3 pi, I'm down to negative 1. And if I go about 8 more, that'll put me out here, back at 0. That would be one period of the sine. If you look at what's going on here, we have 1, 2, 3, 4, we get to another point. 1, 2, 3, 4, we get to another point. 1, 2, 3, 4, we get to another point. So, getting the other side of the x-axis, 1, 2, 3, 4, I'm back at negative 1. 1, 2, 3, 4, I'm back at 0. 1, 2, 3, 4, I'm up at 1. So, a rough sketch of this will look something like this. This is kind of elongated because my scale is so large. I mean, this is pi over 8. That's a pretty small unit. Okay? But that would be a normal sine wave on this scale. Now, let's talk about y equals the sine of 4x. Now, what you're going to see is a horizontal shrink. You're going to see this sine wave is going to go 4 times as fast as this sine wave does. And that's why I set up my scale to be from 0 to pi over 8. Now, when I set up my table for this guy, I still want my top line to be x, but now I need a middle row of my table, 4x, the argument of my sine function. And then I have the sine of 4x. So, this is what my table looks like. I want 4x to be 0 because the sine of 0 is 0. I want 4x to be pi over 2 because the sine of pi over 2 is 1. I want 4x to be pi. That gives me 0. I want 4x to be 3 pi over 2, the sine is -1, and I want 4x to be 2 pi because the sine is back to 0 there. All right, now the trick is figuring out what values of x. Well, first, at 0, there's no big deal, that's just 0. And if you stop and think about it, 4x equals 0, x has to equal 0. And that's the old trick to this. Take the equation 4x, you want it to be equal to pi over 2. Well, if I solve that equation for x, I get x equals pi over 8. So when x is pi over 8, 4x is pi over 2, and the sine of 4x is 1. So you can see that we're starting to go faster already. If you keep on going, you'll notice that you're simply going to divide all these values by 4. 4x equals pi means that x will be pi over 4. This will be 3 pi over 8, and this will be 2 pi over 4, or pi over 2. Now, the length of a normal sine wave period is 2 pi. Because this one's going 4 times as fast, the length of a normal period is pi over 2 units. Officially, the period P is 2 pi divided by K, if we're talking about the sine of Kx. All right, and you'll notice that 2 pi over 4 gives you pi over 2, the length of your period. Now, if I plot these points, I still have 0, 0, but when I get to pi over 8, or pi over 8, I'm up at 1. So on this wave, I just skip 1, and then I'm at to my next point. This is 2 pi over 8, or pi over 4, 3 pi over 8, I'm down at -1. 4 pi over 8 is pi over 2, I'm back at 0. And that is one period of the sine wave. You can keep going, I do expect to see 2 periods. So I've got 1 period here, but just keep going in this manner. I can skip 1, go up to 1, skip 1, back to 0, skip 1, back down to -1, skip 1, back at 0. And so on. Go the other way, you're at 0, skip 1, you're down to -1, skip 1, you're back at 0, skip 1, you're back at 1, skip 1, you're back at 0. So this graph is going to look something like this. And you can see that this graph is going 4 times as fast as the first one. All right, and that's the way we handle shrinking. In the next video, we're going to look at stretching. Thank you.